When we take away the numbers in algebra, we have to replace the number with some sort of symbol so that we can see what's going on. The symbols that we use to replace numbers are called variables. Sometimes it stands in for a number that we're trying to find out by using algebra. Sometimes it stands in for a number that we're going to fill in later. Maybe we need to look up exactly what the value of something actually is, but we know that it's a known thing that we can fill in. Or maybe it's just a really unpleasant number that we don't want to copy over and over again as we're working on a problem, but we can fill it in at the end when it's time to work out some arithmetic. The last thing that a variable might do is maybe we have a variable that just could represent any number. What? Why would that be? We could be making a general statement about numbers, or we could be describing a relationship between two numbers. We'll see variables functioning in all three of these ways in this class. The actual manipulations we're going to choose to do to those variables will depend on what function the variable is serving. Okay, so what does a variable actually look like? Usually, pretty much always in math class, we use a single letter for a variable. So for example, the letter X is very common. The letter Y is also common, but we're not limited to those. We could use the letter A. We could use a capital B. We could use the letter Q, and so on. A quick note on handwriting. Make sure that in your handwriting, these two letters are easy to tell apart. Why is it important to be able to tell apart the letters that you use as variables? The same variable always represents the same number. For example, if the letter A represents the number 2, later on in the same problem it still represents the number 2. Now, once we go to work on a different problem, of course, we can use the letter A again. We would run out of letters really fast if once we used one, it was stuck. But within the same problem, within the same context, the letter A continues to represent the same number. If we want to represent different numbers then, we have to use different variables. Now, different variables don't, strictly speaking, have to represent different numbers. They might, by coincidence, turn out to represent the same number. So if the letter A represents the number 2, B might represent any number, including the possibility that it might represent 2 again. This different variables thing is a little bit tricky. Different letters are different variables, of course, but it's also the case that the capital and lowercase versions of the same letter are different variables. So for example, if little a represents 2, capital A might represent any number. Now, that's a little bit weird. Why on earth would we do that? In applied problems, we typically want the letter we choose for the variable to be related to the thing that it represents. And maybe sometimes we have two things in a problem that both start with an A. And finally, okay, so there are 26 letters in the alphabet. Throw in the capitals also, and that's 52. Sometimes we need even more variables than that. We can do what's called decorating a letter to get a different variable. This is actually the technical term for what we're doing, is decorate. We can use a subscript So x with a subscript 0, x with a subscript 1, x with a subscript 2 are different variables. Or we could have x with a subscript A, x with a subscript B, x with a subscript C. We can even have whole words in the subscript if we want. Different variables. Sometimes we also have a symbol over the letter. We might have an X with a bar over it, an X with this pointy symbol that's called a hat over it. These are also different variables. In this class, we will typically restrict ourselves to using different letters for different variables. However, in science classes and in subsequent math classes, both of these ways of forming a different variable are very likely to come up. So you should be aware of them so that when you see them, you know what's going on.